Good day, everyone. Welcome to this demonstration of Gloo Edge Cloud Native API Gateway via GitOps. What we'll be doing in this demonstration today is take a few minutes just to understand what Gloo Edge is and give an overview of what a Cloud Native API Gateway is. And then we'll look at how to provision and manage Gloo Edge via GitOps tools. And today we're looking at Flux and Flagger. So the demonstration part will essentially cover going from a fresh, nothing installed Kubernetes cluster to progressive application delivery. So the demonstration will do a Bootstrap into the fresh Kubernetes cluster. Will then incrementally secure an application via Gloo Edge in the cluster via GitOps, and then also look at an automated canary application delivery. So what is Gloo Edge Enterprise? Gloo Edge Enterprise is an API gateway that is developed on Envoy, and Envoy is the open source service proxy for distributed systems. It's really the de facto for distributed systems and therefore Kubernetes. And to be Kubernetes native means to be driven by a declarative manifest. Gloo Edge, of course, as an API gateway, needs to deliver enterprise requirements, and this slide just highlights a few of those. What we'll be looking at today specifically is the Kubernetes native way that Gloo Edge has been engineered, and that will boil down to custom resources. Everything you need to do can be declared via a custom resource and a YAML manifest. And we'll look how to use that to add authentication via OAuth and OIDC. We'll add rate limiting, TLS encryption, and even do some routing via the application delivery process. And then, of course, we also do a bit of transformation just to show some of the key capabilities an API gateway should have, and specifically how Cloud Native API gateway allows you to deliver and provision these things via GitOps. And this is just an illustration of what I mean by Kubernetes native and custom resources. So Gloo Edge will be driven via YAML manifests. And because we have a file that is a YAML manifest, we can check that into source control. And that's really one of the foundational bits of GitOps. So everything that we need to do within Gloo Edge, we can do in this declarative YAML manifest fashion. Do take a bit of time to look at our product pages on Gloo Edge and other products. This demo does assume you are familiar with API gateways and probably GitOps and Flux and Flagger to a degree. So if you're not, go back to our product pages and the Flux and Flagger product pages as well. So really, the reason we are here is to look at Gloo Edge Enterprise, provisioning and configuring it via GitOps. And for GitOps today, we'll use Flux and Flagger. Both of those are open source projects and are owned by Weaveworks. So what is GitOps? I think most people have a definition of what they believe GitOps is. But essentially it boils down to having a single source of truth for the system's desired state. So we are able to declare the desired state we want into a manifest, and Git is that single source of truth. And because Git is used, we get the ability to control changes via Git pull requests, and also rollback and audit. So Git really provides us those other fundamental requirements around change. And there we can see here where we have on the left-hand side a environment where innovation, building, testing is happening. It's maybe considered to be dangerous, and the people involved here, we don't want them to have access on our more stable operations and production side. So how do we achieve this? And that's really via automation. So remove the human being from the process, and we want to be sure that there's a process and controls firewall between this dynamic and dangerous environment and into production, but have it automated and as safe as possible. And that's where GitOps really shines in this model. A way I like to describe GitOps as well is to look at it in the sense that Kubernetes really removed the requirement for humans, developers, cluster admins to SSH into machines to configure applications and platforms. So you no longer need to use SSH, you're using kubectl. And GitOps goes a step further where, humans no longer need to use kubectl. They just need to use Git to commit changes into Git. And that's a good way of looking at it as well. So what is Flux? Flux is a GitOps tool, and I highlight it as for the platform. So Flux install 3 key controllers into your Kubernetes cluster, the source controller, and the source controller really looks at where your source of truth is, whether that's GitHub or GitLab or any Git operating Git source control system. And the controller purely looks at these repositories for any change in manifests. And as soon as a change is detected, it will be pulled in. And that's another interesting way of how Flux does GitOps, is that we no longer have external systems, maybe some other continuous delivery system like Jenkins or Atlassian Bamboo, where you have a workflow with a service account, and that service account have permissions to be able to push changes into your cluster. Flux pulls in changes, so no external system to your cluster has any privilege permissions to make changes. So that's what the source controller will do. And as the source controller finds a new update to the repository, the customization controller will pick that up, and the customization controller of Flux is able to translate those manifests into API calls to your Kubernetes cluster and essentially effect that change that you declared in your manifest. Of course, certain packages, services, applications will use Helm to install. So Flux also has a Helm controller, and the Helm controller again also you'll declare a source for the Helm release, and as the source controller detects a change there, the Helm controller will find that and effect the Helm-based change into your Kubernetes cluster. Also, we'll be looking at Flagger, and Flagger is more for the application side of delivery. So once the platform is in place and all the platform services and applications are installed, typically a developer will make changes, have a new image available, new version of the application available. How do we safely deploy that new version into the platform. And Flagger gives that capability to developers and automates a canary deployment. So we'll be looking at how Flagger detects that a new version of the application is available. It will automate changes into Gloo Edge API gateway to control how traffic is being directed to the old and the new version of the application. And it will use metrics to evaluate whether this new canary version is healthy and performant. And based on the metrics, it will decide whether to promote or roll back. So we'll see how Flagger really has been engineered to automatically configure gateway, the Gloo Edge API gateway, to assist with automated canary deployments. So let's look at the demo. In the demo, what we'll do, we'll have a clean Kubernetes cluster, as you can see here. So if we look at what's currently available, we'll see we essentially have a basic Kubernetes cluster with MetaLB and core DNS, and that really allows us to start provisioning applications into it. So the Bootstrap process will be creating the Flux controllers. Once the controllers are in place, they will start looking at the sources that we have defined, and they'll use those sources to start configuring the cluster. So we'll be installing applications, we'll be installing platform services during the Bootstrap process. All application architectures have secrets, so you can think of passwords, SSL certificates with private keys, tokens. Those sort of secrets need to be part of the solution as well. There are many options that you can use. You might be storing that in Vault or in similar secret management services. In this case, for this demonstration, we'll be using SOPs. And SOPs really allow us to continue using declarative manifests to check into GitHub. But obviously those manifests are encrypted. And so with SOPs, we create a secret within the cluster. The private key will allow the cluster to decrypt the encrypted manifest from GitHub. For the application, there is a TLS certificate, and that's the secret that currently sits within GitHub repository in an encrypted fashion, and Flux will automatically be able to pull in that secret and create that secret within the cluster so that we can use it to secure our application. Once we have the Bootstrap kicked off, we'll look a little bit closer at the repository and the custom resources that really builds on what we're doing here today. Once everything is installed and ready, we'll look at how to configure Gloo Edge API gateway. And during that process, we'll be adding the TLS encryption to the application. We'll be adding OIDC-based authentication to the application. We'll be protecting the application with rate limiting and also do some response transformation. And the key thing to see during this part of the demonstration is that there is no refactoring of the application required for any of these capabilities to be added. And that's really the power of Gloo Edge and API gateways, is that it abstracts the application developer from these concerns, and then GitOps allow us to really automate the configuration of these capabilities. And then lastly, we'll go into Flagger, the Flagger side, and automated canary promotion. So during this stage, we'll see how a new version is detected, and then incrementally traffic is promoted to that new version until it's deemed to be safe, and then finally promoted as the new production version. All of these steps are available via a blog page on solo.io blog. So you'll see I'll be using a Git repository. Do go to our solo.io blog space, search for GitOps, and you'll see plenty of GitOps articles in there, including the one we're using today. Okay, so let's kick off the Bootstrap. As I've said, I have created a Kubernetes cluster already. Today I'm using MicroKH. You could use any Kubernetes cluster, whether it's a cloud-based EKS or GKE or Kind or whatever you may choose to have. I've set up a few environment variables and also prepared the Git repository. So you can see here, created 40 minutes ago. So with those things ready, we can start with the demonstration. So I always run the Flux CLI check just to make sure that everything is going to work from that point of view. We are able to connect to the Kubernetes cluster. So we can start the Flux Bootstrap process. So the Bootstrap process will go ahead and start installing the Flux controllers. It will set up its read-only secrets to be able to check all of the sources that are declared, like this Git repository. And once it's completed that, it will use that Git repository to start using the customization controller to start implementing the manifest we've declared there. We'll look a little bit more at the manifests and so on as well once we have Flux bootstrapped. That will install quite a few services, and of course that will take a few minutes. So we'll take that time to look at the repository and how it is used to configure the platform. So you'll see at this stage, it's just starting with the Flux controllers and the source controller. It's the last bit it's doing now. Based on my private Git repository, so my private Git username and my private Git personal access token, those are the pieces of information that's required to bootstrap. Those pieces of information is not stored in Flux anywhere or within Kubernetes. It's just for this bootstrap. It's required so that Flux can set up the sync mechanism with the repository. Okay, so that has completed. I'll show you what this pull command does with the bootstrap. Certain manifests are created in the repository, so I just pull them down as well. So the local and remotes are equivalent. Here, I'm now starting to activate the secrets management. So this is where the first command, I've exported the private key required to decrypt the secrets in GitHub. So obviously for demonstration purposes, I've just used my local laptop as the private key store, and I've extracted it from the private key store. And then I created the secret that Flux can use to have access to the private key, and that private key allows it to decrypt any secrets that are declared in a separate GitHub repository. So let's have a quick look at the GitHub side. This is the repository for Flux. As you see, after the bootstrap, we can now see that the cluster staging is where Flux have added a few of the source controller manifests. So that was part of that bootstrap process and what I pulled down. What I want to show you as well is the secrets repository. So that's a completely separate repository. And in there we have the certificate declared secret. But as you can see, the important private key information is encrypted. And only the Flux controller has the private key in the cluster to decrypt this information. So what we will see now, while the rest of the platform is being provisioned, let's have a look. The key thing to see here is that with provisioning platforms, there are dependencies, and Flux have derivatives inside it that allow you to declare these dependencies. So before we can install the application, we need the infrastructure, the Gloo Edge application API gateway to be installed. So what I have done is declared that within the repository for Flux as well. I'm saying do not install any of the applications until the infrastructure is ready. So let's have a quick look at that. Here we can see within the Flux customization declaration, there's a depends on infrastructure. And then if we look at the infrastructure declaration, what I have put in place there is a health check to tell the infrastructure provisioning, once the Kubernetes deployment of gateway has completed successfully, you can declare the infrastructure installation as successful, and therefore you can start with the application layering. So very, very handy little tips that when it comes to building complex platforms, we are installing multiple applications at this stage, multiple platform services. So these have dependencies, and you need to be able to control that. And Flux makes that pretty easy with its depends on and health checks options. We can see that the GitOps secrets has completed. So at this stage, we expect to see a new secret that has been created automatically within the system. And there we have the upstream TLS. So that's the TLS certificate that we'll be using to secure traffic, provide TLS encryption to the application. So that's ready to be used once we get to that stage. And then we can see here that while it was encrypted in GitHub, over here it has been decrypted. We can have a look at that. A little bit better. We which is of course required for this to work. Okay, so lastly, we'll kick off provisioning. Let's have a look at what's happening at the cluster level. As I said, a lot going on there, and why it takes a few minutes. So Flux installed, the infrastructure services for Gloo Edge API installation is happening. Flagger is installing. We are installing applications as we're going to need them. And we can see Keycloak is what we'll be using for installing or adding OIDC authentication to the application. So Keycloak has been installed. What we need to do is add a few users to the Keycloak data store, so that we actually have a user that we can use to authenticate into the application. So we've just set that up. Let's have a look. Essentially, Gloo Edge is your API gateway, your ingress from the client side into services in the cluster. But now we have Keycloak already installed, and we've configured Keycloak with the users so that we can authenticate into the services. Okay, so while that ticks away, let's have a look at the Git repository structure. Essentially, the structure is at a high level, got 3 levels, which is the application and infrastructure. So applications is where your developers will be pushing their images and code. And we have the base application. So this is, the generic application, how it's declared and how it needs to be installed, everything it needs to run in Kubernetes. But then also, each application might have slight differences for each environment. So in staging, the application has a different authentication configuration perhaps, and we're able to just bring in those little customizations per environment via a very easy structure and an easy YAML manifest declaration. And we'll see these during the demonstration as well. As you can see, the resources, this is normal Kubernetes native manifests for custom resources that are declared. And we'll be configuring these as need be, checking them back into GitHub. The source controller will detect that, the customization controller will detect that, and apply them automatically into the cluster. On the infrastructure side, we are installing Gloo Edge API Gateway, we're installing Keycloak and Flagger as well. So these are more platform level services, and we are able to essentially do the same as per applications, provide any environmental customizations as need be. But these services automatically get installed based on the Git repository. So we can see this directory structure in here. So applications, base, all the applications that we want, how they are installed. And then in staging, they may have each little customization that's required. On the infrastructure side, we have the infrastructure services, Helm declarations on where the Helm repository is, and all the required parameters for that. And these are all now installing. So let's have a look at our customizations. Let's see. Okay, we can see that the infrastructure side has completed. That allowed the applications to install as well. So at this stage, we're expecting to see most of the required components are up and running. So at this stage, as I've said, with a few Bootstrap commands, we were able to install platform services, applications, and everything was done in an automated fashion. We haven't even made any commits into Git. So let's start looking at that. So we've done the Bootstrap. Now we want to say, okay, this application should now be up and running. Great. So everything has been automatically installed so far. But the application is using HTTP plain text. And we want to start securing the application. And we're going to demonstrate how to do that without refactoring the application. So let's add TLS encryption, use that certificate secret that was created to add TLS encryption. So this is where we start looking at the resource manifests. I've obviously pre-prepared them just so that we don't spend too much time looking at updates to manifests. So this custom resource is a virtual service resource, which is a Gloo Edge custom resource. And a virtual service is telling the API gateway where to listen and how to route traffic. So this is essentially creating that listener on the proxy side, and it's telling it when request comes to this listener, how do we route it? And we want it to go to the Kubernetes default pet clinic application. And we'll come back to this custom resource to add other capabilities as well. So any request coming into the API gateway will be routed to this backend at this stage. And now we've said, okay, well, we want to add TLS encryption to this application. So all we need to do is update the virtual service and then push that into Git. No SSH, no kubectl. So the commit has gone in. Let's look at our customizations. And here we can see another tip. We can use the commit short handle to check whether the source controller has picked up the change and whether the customization controller has implemented that. So the current release is still the old one. The new one is 54D. So if we have a look, you can see now it's picked it up and it's started the reconciliation. So this change should be in the next few seconds. Okay, great. We can now see that commit has been reconciled and the application should now not work on port 8080 anymore. So close that. And if we go to HTTPS, you can see that the certificate and everything is ready to use. Very, very powerful capability of API gateways to add the security to applications without requiring application refactoring. Okay, so that's great. We've now got TLS encryption. So that allows us to take the application security a step further, where we can say, well, we now want to add authentication to the application. So we're going to integrate with Keycloak or OIDC and use the user credentials we created in there to provide authentication to the application. And again, all we're doing is we're going into a manifest file, checking everything in, and that will allow us to commit the change and effect the change without requiring to go to kubectl or the cluster in any way. If I just remember where I put this, there we go. I think that should, no, I need another level. Okay, so for the authentication configuration and integration, we need to tell Gloo Edge where is the OIDC service. So we need to provide some parameters in the authentication configuration manifest. First thing is the application URL that we are protecting. Update that. And then there will be the secret that it needs to use, the client ID. So that Keycloak can trust this request. And then lastly, we just configure the Keycloak URL. So with the auth config resource in Gloo Edge, we are able to configure OIDC authentication-based systems, OAuth, any number of options are available. In this case, we're just using Keycloak. So that's configuring, that's telling Gloo Edge where the OIDC service is, Keycloak. Then we need to go to the application. So we're going to the application repository and we're saying, okay, in your customization, we are now adding that authentication configuration. So again, a little bit pre-prepared so that we don't sit here too long. I'm looking at typing. And then the last bit that we need to do is go to the application's virtual service. So this is where we have the listener and tell the listener now as traffic is coming in, it needs to be directed to the external authentication service. We've just declared that authentication service in the manifest as well. So let's change that. And then to effect and add authentication, we commit into Git. So let's look at the customizations. As we see, this time it's already picked it up. So a little bit quicker. Obviously, the intervals is configurable. Lots of flexibility within how you declare, how these controllers check and what they check. And there we can see that change has already been effected. So now what we expect is to be prompted for authentication. So let's authenticate. Great, excellent. So again, no application refactoring and no interaction with the cluster as such, only Git commits. So that's really the power of Kubernetes native and the effect of Gloo Edge being Kubernetes native as well. It is developed to work with that Kubernetes native resources. Okay, let's continue with securing the application. Another key capability of API gateways will be rate limiting. So often, some applications need to be guarded in terms of rate limiting. People overusing something may take resources from more important services in the cluster. So rate limiting is one of those API gateway capabilities that organizations very quickly need to look at. So we'll enable rate limiting. Again, we go into the customization so that Flux knows we are making a change and what it needs to affect that change. So here we have told it to look at the rate limit YAML manifest. So let's see what that is going to do. Better way to see that is probably in here. And we can see it's a simple Gloo Edge custom resource again. And here we declare that there's a rate limit of 10 requests per minute with this rate limit policy. So nothing too wildly exciting there. So we go to the applications virtual service again. And we enable that rate limiting policy. And we commit that. And then look for the reconciliation. So still on the old configuration, waiting for the new commit to be reconciled. Just unlucky. These things can be forced, but generally it's not necessary. You just need to pay a bit of patience in this very automated world that we're in. Even waiting for reconciliation feels too much. But there we see that's now been applied, so we've got the new configuration ready to test. So with rate limiting, we said this application should now be rate limited to only 10 requests per minute. And to see that, we'll use the developer tools in the application. And here we can see that the rate limit policy has kicked in for 2.9. Too many requests has been applied. Obviously that was less than 10 requests, but it's a microservice architecture. There's many asynchronous calls happening. Not that important for this demonstration, but we can see that change has been affected again, but not a very user-friendly and good user experience here. So let's use the API Gateway's capability to effect a transformation to change that response to the end user. So again, we're able to go to our virtual service for the application, and in there add the transformation declarations in the Gloo Edge virtual service. And can see that the transformation will be looking for that response code of 429 and then provide us a better user experience in terms of the response. So let's get out of that. And then we affect the Git. Okay, that will take a few seconds or minutes. We can close over here. Shouldn't need that now. And what we should see is this nice blue response to the user telling it that the service is no longer available. Customizations can, of course, be done for numerous reasons that you will want to make these transformations. HTML body request and response transformation is probably one of the entry-level ones. Okay, and yeah, we can see that transformation configuration has been added. So let's go back to the application and refresh it. And there we can see that the API gateway has picked up the 429 and transformed that response. And again, that is without making any application refactoring. So it may have felt quite laborious in configuring all of this, but this is for the demonstration. The demonstration is about Gloo Edge API gateway being cloud native, Kubernetes native, and that means you can use GitOps. And so we did a few iterations of that GitOps change. Really, that was part of the point. To see that a couple of times and to see how powerful it is, very business-centric capability like an API gateway can easily and safely be configured in the GitOps fashion. It's not just for low-level services. So very, very useful. Of course, now that this manifest and all the manifests that we updated during this demonstration so far are committed into GitOps and GitHub, there's no requirement to redo that again. Next time you want to build this API gateway, all of that will be in place and ready to be used. So let's go over to the next section where we are going to use Flagger to automate the canary promotion. And what we'll see here is that a new version of the application is found. Flagger will use Prometheus metrics to test that new version, and based on that, we'll decide whether it should promote more traffic to that new version until eventually it's declared safe at 50%, and the old production version is decommissioned and no longer receives traffic. So that shifting of traffic is done by Gloo Edge, the API gateway. Again, a key capability of your API gateway is to be able to control traffic in this fashion. And Flagger takes that control and automates it for you as well. So let's look at that. For Flagger, we have already installed it, so we can just have a look at that as part of that initial Bootstrap process. It was already configured. So we can see all the resources is ready. Again, there's an application, so there's a virtual service telling Gloo Edge where to listen and how to route that traffic to the application. And then the key capability that Flagger automates is the update of the route table. And it's the route table that we use to shift the traffic. So Flagger will automatically update that. Previously, we were updating these via GitOps in a manual fashion. Flagger will do that for us. So part of Flagger, we need to tell it how do we define this canary deployment. In this case, we are saying that we want to promote traffic in intervals of 10 seconds. incremented by 5%. Once it reaches that 50% traffic and everything is still healthy, we'll consider the canary as successful. And Flagger will look at metrics. It needs to know that this new application is healthy and performant. So a few metrics that it will look at is whether any 500 errors are being seen. If that's happening, obviously it will wait before promoting. It will also look at the 99 percentile and make sure that that is less than 500 milliseconds. So those would be the two criteria that it uses to determine the health and performance of the new version. And based on that, it will continue with the rollout. If it doesn't meet any of these conditions, it will automate the rollback and stop the canary deployment. In this case, we, for metrics to be generated, there needs to be load. So we've got a load generator that's going to take care of that for us in this optional sort of testing webhooks that's included in the canary manifest. Okay, so let's do that. Let's go and add a new deployment, telling it to use a new image. We are updating. So what we should see is Flagger detecting a new version is available. So we can see it's already started and found a new version, and it's starting the canary deployment. And we'll see as it starts shifting traffic, we'll have a look at the Gloo Edge resource that has been updated automatically. So here we can see that Flagger has advanced the canary deployment. So traffic has been shifted 5%. And there we can see, so here we have the Gloo Edge custom resource that is being configured by Flagger for this canary deployment. And we can see here metrics have shown that traffic is still good. So we should now see this route table has been updated accordingly as well. So the canary is being slowly promoted in terms of more traffic in an automated fashion. It's gone up to 20, 25. I'll let that run through. Slowly walking through these steps now. 30%. And with Gloo Edge API Gateway, we are able to delegate this type of control to the developer level. So while the virtual service, we may feel that that needs to be at the cluster operator level, but application deployments, that's really up to the application owner and the developer teams. So Gloo Edge allows you via route tables to delegate that function down to the application owner. And you no longer need to rely on the API gateway operator to help with that deployment. So let's have a final look. So at 50%, we said that is now considered to be healthy, and we can see the route table has reached 50%. Flagger has determined that that new version is still performant and healthy, and therefore all traffic is now switched to the new application. And that's it really for the demonstration. Just wanted to take a few minutes to quickly run through that. I'll remind you to please go to solo.io blogs, where we have other GitOps tutorials and blogs. This one has a blog there for the GitOps and steps that I used. We have many other resources that you can look at as well. You can find us on Slack if you want to ask any questions. Hope to see everyone out there soon.